and welcome to our video. We are the Einstein group number 39 and we will show you the process on how to get the Ohm's law. Now, I will show you my group members for this video.
Hello and good day, sir. I am just Sir M. Firmeza, and I was assigned to do the procedures in our group. So before I'll proceed to show you or tell you our step-by-step procedure in this lab experiment number 4, I will need to share my screen first. So the first thing that the group should do is to discuss with their group members if what value of resistance will they be using in the lab experiment number 4. But they should also take note that the numbers that they will be using or the values that they will be using should be in increasing numbers from trials 1 to 5. So after that, they should open their Canvas account and look for physics in their courses, and then look for mode. And then after opening the physics course, they should look for the modules, and then they should click the PhET simulator and wait for it to be fully loaded. And after the link or the PhET simulator or the application is fully loaded, they will see intro and lab. But for this laboratory experiment, we will be using the lab. So click for lab. And then the group should now already start running their datas. So in the upper right corner of the simulator, click for labels for us to determine the names of each materials here in the simulator. And then also click for values for us to determine the every values that are encoded here in each materials to be used later on. And also click for the conventional for us to see the flowing from positive to negative. But we should take note that the electron flow is in the reverse direction. After that, click and move the voltmeter together or attach with its terminals, positive and negative terminals, and also for the ammeter to determine the current or to measure the current, I mean. Note that you may also return it inside its box if you wish to not use it. But for now, we are using it, so we will not use it. We will not place it in its box again. So in the upper left corner of the screen, you will see wires, battery, light bulb, resistor, and switch. But for now, we will be using wire, battery, resistor, and switch only. So click for the battery. So take note that the battery cannot be stretched, but it can be attached with another battery or below. But for now, let me delete one battery because we will be only using one battery for this activity. And then you need to also click for the wires. So attach the wires over from here in the battery and then stretch it. So take note that the wires can be stretched as long as you want it to, but take note that not too long because it is not it is not this, or I mean the simulator does not have enough space for it to be too much long. And then also click for the resistor. So the value of on it, or the value of the resistor, can be changed depending on the discussed value by the members, by the group earlier. So you just need to click the resistor, and then there is a button below that will appear. And for example, the group decided in the first trial, they decided for 10 ohms, 10 ohms. Let's just put it in here. And then let's also use, or let's also grab and place an a switch over here below, and then add more wires. Add more wires. I mean wires, not switch. There it goes. And now it is finished. We are now done placing all the wires, or adding more wires. And then if you want, and then now let's place an ammeter over here, but we cannot place it. So we need to click the broken circle over here, and then cut, and then minimize the wire, and then attach the ammeter, and then add another wire to connect all the materials. Yeah. So the next thing that the group should do is to place the voltmeters probe to the broken circles along the ammeter to determine its voltage. And now, I mean, take note that you can also click for the battery. You also change the voltage of the battery by just clicking it double times, or one time, and then you just need, or you just move it, slide it down here in the knob here. For example, I want 24 volts, and after that, close the switch and start recording the data gathered on your tables. Nice. So we can see that we have 24 volts, and it has a current of 2.40 amperes, and it has a resistance of 10 ohms. And that ends our procedure for the laboratory experiment number 4.
In this laboratory experiment, we were tasked to verify the Ohm's law principles. During our lesson, we have learned that the voltage or potential difference between 2 points is directly proportional to the current or electricity passing through the resistance, and directly proportional to the resistance of the current. The formula for Ohm's law is V equals IR. This relationship between current, voltage, and resistance, we were also able to understand the following. Ohm's law is a law in electricity. It is a strength of the direct current is directly proportional to the potential difference and inversely proportional to the resistance of the current.
Resistance is measured in ohms, symbolized by the Greek letter omega. Ohms is named after George Simon Ohm, a German physicist who investigated the relationship between voltage, current, and resistance. Voltage is a representation of the electrical potential energy per unit of charge. If a unit of electrical charge were placed in a location, the voltage indicates the potential energy of it at that point. In other in other words, it is a measurement of the energy contained within an electric field or an electric circuit at a given point. Electric current is a stream of charged particles, such as electrons or ions, moving through an electroconductor or space. It is measured as the net rate of flow of electric charge through a surface or into a controlled volume.
Observations. In this experiment, we were able to verify the principle of Ohm's law, in which we were able to observe that based on our tables and graphs, both the experimental and theoretical values of current decreases as the value of the resistance increases. The value of the theoretical voltage also decreases as the current decreases. There is no significant difference between the theoretical and experimental values of voltage and current. In getting the theoretical voltages of the 5 trials, we used the formula theoretical voltage equals to experimental current multiplied by resistance. That gives us a 30.0 voltage in the first trial, 29.96 in the second trial, 30.03 in the third trial, 30.06 in the fourth trial, and 30.0 voltage in the last trial. And for the theoretical current, it equals to experimental voltage over resistance that resulted in a decreasing number of currents from trials 1 to 5. Therefore, given voltage and depending how big the resistance is, then it will depend how the current will flow through the resistance.
Based on our data observations, we were able to come up with our analysis. First is that the increased assigned resistant values, the resulting experimental current is decreasing through the 5 trials. Second is that computing the theoretical voltage, the results are seen to vary over time, but the values does not seem to vary away from the experimental voltage value of 30 volts. Third is that both the experimental and theoretical values of the current decreases as the value of the resistance increases. Fourth is that the value of the theoretical voltage also decreases as the current decreases. And lastly, there is no significant difference between the theoretical and experimental values of voltage and current. As you can see, there are only 3 values shown. The upper line, which is for the voltage, and the lower line is for the current. This is actually 2 lines in one, because as said, the values between the theoretical and the experimental of the voltage and the current are very similar, so they overlap each other. But when you remove the values of the theoretical voltage and the theoretical current, as you can see, we can see the experimental voltage value and the experimental current value, which is, as I said, very similar to the theoretical values.
I was assigned to do the task in conclusion. The main objective of this laboratory experiment is to verify the Ohm's law principle, in which Ohm's law states that the current flowing in a circuit is directly proportional to the applied potential difference and inversely proportional to the resistance in the circuit. And through conducting this laboratory experiment, the Ohm's law principle have been confirmed in this laboratory experiment because of the relationship seen between current, voltage, and resistance. With the information collected, based on our gathered data, observations, and analysis, the current is directly proportional to the voltage and inversely proportional to the resistance. We were able to conclude that there is no significant difference between the theoretical and experimental values of voltage and current. Therefore, given voltage and depending how big the resistance is, it will depend how the current will flow through the resistance.
Through this experiment, we were able to verify the Ohm's law principle. Based on our gathered data, we were able to make our discussion, observations, analysis, and conclusion. In our discussion, we have stated what we have learned as stated the Ohm's law. We also gave definition in resistance, voltage, and current. And based on our table, we also made our 3 general observations, and as for our analysis, we were able to come up 5 of it and explain our graph. And as for our conclusion, we stated the relationship between the voltage, current, and the resistance. We also mentioned our major findings about this laboratory experiment and confirmed or verified the Ohm's law principle. So I am Diestro, the validator of this group. Thank you for listening and have a good day.